this video we're going to have a look at problem solving with equations. There's 6 steps we generally go through. Firstly, we draw a picture if it's relevant. If the problem's about numbers, we wouldn't draw a picture. Step 2, we define a variable. I call this the let statement because we say let x or a or whatever variable we're using equal what we're trying to find out. We also then write an equation. At this stage, we're using one variable, one equation. We solve the equation by backtracking using the inverse operation. We check our solution in context of the problem, and then we write a final statement and include units if relevant. We're going to go through 2 examples. The length of a rectangle. Now first of all, I'm going to start with step 1 and I'm going to draw a rectangle. Doesn't need to be to scale. It's just to get an idea of the problem. So the length of the rectangle, poorly drawn, is 3 times its width. Now I'm looking at defining the variable. Given that we can write the length in terms of the width without having to use a fraction, I think I'm going to use let x equal the width, and then I'm going to update my diagram with the width being x and the length being 3x. So the length of the rectangle is 3 times its width. Step 1, we've drawn a picture, and step 2, we've defined our variable. If the perimeter is 20 centimetres, write an equation. Now we want to write an equation for the context of the problem. We don't want to try and start solving it. So here, the perimeter equals 20 centimetres. Well, we know 3x plus another 3x plus x is the perimeter. That is 8x equals 20 centimetres, leaving the units out of the equation. We need to write an equation and solve the problem. Backtracking, 8 times x is 20. If we divide both sides of the equation by 8, we get 20 over 8. And in this case, I'm going to use decimals. You could stay with fractions, 5 over 2, but I'm going to put it in 2.5. So x equals 2.5, and find the dimensions of the rectangle. Now let's actually check that we're correct. If the width was 2.5 and the length is 3 times it, 7.5, let's add these up and make sure they equal 20. 7.5 plus 2.5 is 10, plus another 10 is 20. Yes, I'm happy. I like to give myself a little tick. And then step 6, we write our final statement with units. Therefore, the length is 7.5 centimetres and width is 2.5 centimetres. Let's go through a second harder problem. Sue runs from home to the park, then walks back home. Now I'm going to start to draw a picture here. Here's Sue's home, and here's the park. And she runs to the park. Okay, so she runs to the park, and then she walks back home. She runs at 3 meters per second, and then she walks at 2 meters per second. So she walked on her return journey 2 meters per second. The entire trip takes 50 minutes. So we have speed, we have time, we need to find the distance. The question often gives you a hint for what variable we should be defining. Since we're finding the distance from her home to her park, let's let d equal the distance that we're trying to find out. Step 1, we've drawn a picture. Step 2, we've defined the variable. Now we need to write an equation. Given that speed equals the distance divided by time, we can rearrange this formula to get time equals the distance divided by speed. And the time to the park plus the time back will equal 50 minutes. And we don't want to get tricked on the units here. Our speed was given in meters per second, yet our time was given in minutes. So the time it takes to get to the park is the distance it travels, d, divided by the speed, 3. The time it takes for the return journey is the same distance divided by 2, and we know that these equal 50 minutes. Now, 50 minutes, but we're working in meters per second, we need to times it by 60 to get seconds. So it'll be 3,000 seconds. Here's our equation. Step 3 completed. Step 4, we need to solve the equation. Here we've got some algebraic fractions. The lowest common denominator is 6. So we have 2d over 6 plus 3d over 6 equals our 3,000 seconds. 2d over 6 plus 3d over 6, 5d over 6 equals 3,000. And now we're going to start solving by backtracking. Opposite or inverse of dividing by 6 is timesing by 6, so we get 5d equals 18,000 seconds, and then we divide it by 5, so d equals 3,600. So our distance is 3,600 meters. Now we could do a check putting it back into the original problem. I've run out of room here, so I'm going to assume it's correct and write our final statement. Therefore, the distance from home to park is 3,600 meters. So these 6 steps are useful to remember. Draw a picture, define your variable, write your equation, then solve it. Make sure your equation's in terms of the context of the problem. Don't try and start solving before you've written it. Check your solution and write your final statement including units.